Page 171, lesson 3.2 is on solving inequalities using addition or subtraction. So one of the things it talks about on this page is equivalent inequalities, and those are inequalities that have the same solutions. What they're pointing out in the key concept box, the addition property of equality, basically says if one thing is greater than something else and you add the same number to both of them, the one will still be greater than the other. So for example, 5 is greater than 4. If you add 3 to both of those, 8 would still be greater than 7. Negative 2 is less than 0. If we add 1 to both of those, negative 1 is still less than 1. Okay, so this is similar to what we did, addition property of equations, where we added the same number on both sides of the equation. This is just with inequalities rather than equal signs. So basically it just says we're allowed to add the same number to both sides of an inequality, and the inequality will still stay the same. So if you look at problem 1, they're asking what the solutions are of this inequality. Basically, just like we did for solving equations, whatever they're doing, we're going to do the opposite. So you could say they're subtracting 15. I'm going to add 15 on both sides. And when you do that, you get x is greater than 3. At that point, you could graph that on a number line. Remember, we can do this above the number line so you can see the circle better. That would be an open circle at 3 going to the right. And we could also do interval notation if we wanted. Would be a parentheses 3, comma, infinity, parentheses. So if you look at the got it 1, they want us to find the solutions of this inequality and graph the solutions. So this one, they are subtracting 5. So we can add 5 on both sides of the inequality. And n is less than 2. So n is less than 2 is going to be an open circle at 2 going to the left. If they ask for interval notation, would be negative infinity to 2 and parentheses on both sides. The next part in your book talks about our answers have infinitely many solutions. So if there's infinitely many solutions, we're not going to check them all because we would just keep going. Well, we haven't checked this yet. We haven't checked this yet. But what we can do is we can check some things that are part of that solution. We could also check the endpoint just to make sure whether it's supposed to be included or not. So if you look at problem 2, that one on the side with the variable, they're subtracting 3, so we can add 3. And this one, I would recommend you switch this around. Inequality opens towards the 13, so if you flip-flop, then your inequality will change directions there also. Okay, just a matter of perspective. So x is less than or equal to 13. So you graph that closed circle at 13 going to the left. And then they just tried some values to see if they worked. So they said, oh, it looks like 10 should be an answer that should work here. And so they tried 10. Oh, sorry, they tried, actually first they tried 13, which was the end point, and that ended up being equal. Okay, the end point is going to be the or equal to part if there is one. So 13 worked. 12 looks like a possibility that's part of our solution. So they tried 12 and they got 10 is greater than or equal to 9, and that works. So we know 12 is part of the solution, means we know our arrow is going the right direction. Okay, so that's just kind of a double check at the end. And if you're confident with what you did, you're probably okay. But if you have time, it's not a bad idea to do that, just to check that you did that correctly. So if you look at the got it 2, they want us to find the solutions for this inequality, graph, and check the solutions. So on this one, they're subtracting 11. We can add 11 on both sides of the inequality. Negative 2 plus 11 would be 9. So we've got m is greater than or equal to 9. We can go to graph that. If you want to just show the 0 and the 9 is probably sufficient. So this says greater than or equal to, so it'd be a closed circle. And then it's greater than or equal to, the numbers greater than that would be going to the right. And you know, you can put numbers around that too, if that, you know, just make sure you're in the right mindset. Obviously 10 is greater than 9, so we know we're going the right direction. Like the book suggested, you could test the endpoint. You could try 9 back in the original and see if it works. So that'd be negative 2 is greater than or equal to negative 2, and that works. So that's how we know we were correct in doing a closed circle. And then if you try something further to the right, I mean, you can try 10. I'm going to try 11 just because it's an easier problem then. Okay, that says 0 is greater than or equal to negative 2, which is true. So 11, and that's part of the direction our arrow is going, so we're in good shape there as well. If we were doing interval notation, going left to right, so that'd be a bracket, 9, comma, infinity. So the next thing we're looking at is the subtraction property of inequality, basically more of the same, only instead of adding, we're subtracting. So if you subtract the same number on both sides of an inequality, the inequality still works. So, for example, we know negative 3 is less than 5. If you subtract 2 from both sides, you would have negative 5 is less than 3, and that's still true. 3 is greater than negative 4. If you subtract 1 from both sides, that says 2 is greater than negative 5, and that's true as well. Okay, so this subtraction property just says we can subtract the same number on both sides of the inequality. So if you look at problem 3, so they were adding 6, we could subtract 6 on both sides. So t is greater than negative 10. Be an open circle at negative 10 going to the right. So they got it 3, they want solutions and graphing this one. So this one they are adding, so we can subtract 12 on both sides. So we got negative 13 is greater than or equal to y, or we can flip it around and say y is less than or equal to negative 13. One thing on this problem, if you wanted to, before you start working the problem out, you could switch it around. You could just change it to y plus 12 is less than or equal to negative 1, and then subtract 12, and you'll get the same answer. So it's just a matter of, you know, when do you want to change the direction around. And not to say that you have to, but, you know, personally, I just have a hard time. If I don't have the variable on the left, I have a hard time thinking about what direction this is going to go. So less than or equal to is going to look like that. And that would be negative infinity to negative 13 with a bracket if we did interval notation. Problem 4, we've got kind of a real life situation here. The hard drive on your computer has a capacity of 120 gigabytes. You've used 85 gigabytes. You want to save some home videos to your hard drive. What are possible sizes of the home video collection you can save? All right, so we've got 85 already accounted for. So one way of doing this, we could say 85 plus whatever size of the videos we can still have needs to be less than or equal to 120. If you subtract 85 on both sides, you get less than or equal to 35. So it would need to be less than or equal to 35 gigabytes. And I know you could have just done 120 minus 85 and gotten 35 and just say, well, it's got to be less than or equal to that. If they ask you to specifically write an inequality, you need to do it this way though. Or you could put v as less than or equal to 120 minus 85 would be another way if you have to write an original inequality. So the Got It 4 club has a goal to sell at least 25 plants for a fundraiser. They sell 8 plants on Wednesday, 9 plants on Thursday. What are the possible numbers of plants the club can sell on Friday to meet their goal? Okay, and so by possible numbers of plants, we can just do an inequality answer would be sufficient for this one. So one way of doing this, we could look at what all we've done. We sold 8 plants on Wednesday, 9 plants on Thursday. You want to use P for plants or F for Friday or whatever. You want to just use an X, whatever you want to do there. But the deal is we want to sell at least 25 plants. So what we're looking at, the 8 plus 9 plus P, that's the number of plants that we've sold. So if we want that to be at least 25, then that would have to be greater than or equal to 25. The amount we sold has to be greater than or equal to 25. This one, once we have that set up, then the 8 and the 9 are on the same side. We can combine those together, which would be 17. So to get rid of that, that's a positive 17. We need to subtract 17. So P is greater than or equal to 8, which means they need to sell at least 8 plants on Friday. Going back to the Got It Part B, it says, can you use the same inequality symbol to represent the phrases like at least, no less than, and greater than or equal to? So based off the last one, we know the symbol would be greater than or equal to for that one. The question is, are all of those meaning greater than or equal to or not? And the answer is yes. All of those phrases mean greater than or equal to. So yes would be the answer to that question. So if we look at the lesson check number 2, they want us to solve the inequality graph and check your solutions. So on this problem, the variable is on the right side. If you want to switch things around to start, you can. If you want to switch things around after you solve it, you can. Or you can be careful and not switch it around. So I'm just going to switch this around. Now when you switch this around, you're literally taking exactly the same stuff. So don't change the order of what's on the sides. You're just changing what's, left side for right side. So D minus 2 would come over here if we switch this. It's opening towards the 8, so it still needs to open towards the 8. All right, again, it's a matter of perspective. Like, I'm older than you, you're younger than me. It's the same thing, just a different perspective. So then to solve this, they're subtracting 2. We can add 2. D is less than or equal to 10. And then they want us to graph this. Be a closed circle going to the left. and then you could check your solutions. You could put in a 10. 10 was our end point, so you could put a 10 back in to see if it works, and it does. I noticed my graph goes over the point 0, so 0 is a nice number to try sometimes. That would say 8 is greater than or equal to -2, so that works. And again, we've got an infinite number of possibilities. We're not going to sit here all day and try them, but the end point and another point, if you have time, is a good idea to check out. If we did interval notation, we're going from left to right. So going from the left, this goes to -infinity, and it's ending at 10. It includes 10, so that would have a bracket next to it. Finally, if we look at number 5, a cyclist takes her bicycle on a chairlift to the top of the slope. The chairlift can safely carry 680 pounds. Cyclist weighs 124 pounds. Bicycle weighs 32 pounds. What are the possible additional weights the chairlift can safely carry? So, one thing we didn't really talk about too much earlier, but always when you're doing problems like this, it's a good idea to define your variable. Look at what you're trying to find. That's going to be your variable. So you could say, let A represent additional weight the chairlift can safely carry, and I could say in pounds. Okay, A for additional weight if you want to do W for weight, P for pounds, X just because. So if we were writing an inequality, we've got 124 plus 32 plus our additional weight needs to be less than or equal to 680. These numbers we can add together, which would be 156. Then to solve, we would need to subtract 156 on both sides of the inequality, and that should be 524. So we could say it could carry 524 pounds at the most. I don't know if I would want to gamble that to go right to that exact amount that it's saying it can hold, but technically that should work. So this gives you an idea of how to solve inequalities using addition or subtraction. Have a good day.